Alright, Assalamualaikum warahmatullahi wabarakatuh. Okay, hari ini saya akan present mengenai survival analysis lah. Macam mana kita nak perform the descriptive analysis and also the regression analysis for survival. Okay, straight to the point, I will use the stroke outcome data for this demonstration. Okay, first of all, please okay, make this habit lah to kita kena buat analysis workflow. Okay, analysis workflow ni kita buat in list. Okay, tips untuk list ni, kalau kita kita akan keep on tambah list as we go on with the analysis. So macam mana kita nak buat list tu tak serabut, so kita boleh guna just buat list of number one sahaja. Okay, one, prepare, environment, load, data wrangling, analysis and interpretation. So if you have another subheading, you just add, okay, one dot let's say data summary. Okay, so this way it will not disturb the flow of the list. Okay, bila kita need, dia akan keluar 1, 2, 3, 4, 5, 6 juga. Okay, alright. And then the second step is to prepare environment. I will use library Heaven. Heaven ni kita guna untuk kita read any various of data format lah. So for example, in this tutorial I will use the DTA format. So dia boleh juga untuk baca data lain. Okay, so the purpose is to read various format of data set lah. So for tidyverse, saya guna tidyverse untuk data wrangling. Kita boleh guna mutate function, kita boleh guna mutate if. Mutate if bila kita nak convert the label variable into the factor variable. Mutate we can use to generate a new variable. Okay, contohnya kita nak generate BMI from height and weight. Contohnya kita nak generate the variable of duration from date of admission to date of discharge. Okay, so we can use library tidyverse. Plier ni kita guna untuk kita in this case I will use to revalue the variable. Contohnya kalau dalam dataset tu dia buat gender, 0 female, 1 is male. So bila kita analyze, dia akan keluar dalam table 01. So aesthetically it's not nice. So I will use the plier library to use the revalue function so that we can assign 0 for female, 1 for male. So that in the final table it will present as female and male. It's more meaningful. All right, and then I will use the gtsummary package to create a presentation ready table. It's very useful. Okay, this library is very useful. The gtsummary, we can use the TBL summary to summarize our data set. We can use the TBL_regression to create a regression table, a presentation ready table for the regression analysis. And then for these purposes of survival analysis, I will use the library survival. We can use the surfit function. We can use surfit function ni kalau kita nak perform the Kaplan Meier estimate. Okay, untuk regression analysis kita akan guna Cox PH. Okay, and then from the same library survival kita boleh test the assumption for proportional hazard assumption, which we will use the cox.zph function. Okay, and then we can plot the assumption of proportional hazard using ggsurfplot. Okay, and then I will also use the library lubridate. Lubridate ni kita guna untuk kita dealing with the date. Okay, kita nak cari the duration between date of admission to date of discharge, kita guna library lubridate. Okay, kita load data. Alright, so kita run dulu all the library, and then we load the data. Okay, I name the data as data, senang. Okay, read underscore DTA, kita baca data nama stroke underscore outcome dot DTA. Jangan lupa letak pembuka dan penutup kata ni. It's very important. If you miss this, you will end up with error. Okay, I will use glim. Glim ni kita nak tengok the classes of the variable. It's very easy to see the classes of the variable. Okay, kita cuba run. Alright, when I run this code, you can see that the sex is label. Okay, event, DM, hypertension is all in label. If it is in label, we cannot use it for regression analysis because the result will be different lah. Okay. Next step is data wrangling. Okay, kita buat data wrangling. Kita convert label to factor dulu. Guna library tidyverse using mutate underscore if function. Okay, kita tulis data, inverted arrow data. Kita buat pipe. Okay, pipe ada untuk inverted arrow, the shortcut is ALT and minus at the same time. Hit ALT and minus at the same time. Okay, for the pipe is Control Shift M, hit at the same time, and you will get the pipe. Okay, and then write mutate if underscore, and then we write is dot labeled, comma, saya tak tahu ni kita panggil apa, tapi saya panggil ulat lah, senang, ulat as dot factor. Alright, and then it will convert all the label into the factor variable. Okay, the second one is kita dealing with the date. It's very important in survival analysis. Okay, data, inverted arrow, data, pipe, mutate. Kita mutate guna mutate function. Kita state apa new variable yang kita nak, sama dengan kita nak ambil data daripada dataset mana, dollar, kita nak pilih variable mana, ni tolak. Okay, this is sign minus sign using lubridate library. Kalau tak run lubridate, you tak boleh nak run this function. Okay, then kita nak tolak dengan data dollar date of discharge. Dan kita nak mutate pula duration ni into as duration. Okay, mutate the duration to the DUR variable into duration. Okay, and then after that, this line of code will produce a duration in second. So kita nak convert kepada days, kita kena guna mutate. Mutate ni from tidyverse. Okay, kita make a new variable duration in days by dividing the DUR variable with the days. Dan kita nak satu sahaja titik perpuluhan. So kita put 1. Okay, kalau nak dua. So kita nak satu je lah. Days kan, 1 hari, 2 hari, 3 hari. Okay, and the next step for data wrangling is I want to revalue. Okay, the sex, the race, the event. Okay, I want to put 1 as male, 2 as female, 0 as others, 1 as Malay, 0 as alive, 1 as deaf, to make a meaningful presentation during the final result later. And then I will use glim function to look back what I have done. Okay, kalau kita run semua ni, okay, kita glimpse, kita boleh tengok kita dah ubah the label into factor. Okay, kita dah tambah dua variable DUR duration in second and also the duration in days. So it settled. Alright, and I have revalued some of the variable, the sex, female, male, Malay, others. So kita assign a name to the number. Alright, okay, this is the most important part of my tutorial today lah, which is the analysis. Okay, first we want to compute the overall Kaplan Meier analysis, and the second one, we want to compute the Kaplan Meier analysis for the variable race. Okay, for the first process, I will compute the overall Kaplan Meier analysis, kita bagi nama sebagai km.overall. Okey, kita guna yang ni kita guna library survival. Dalam library survival tu kita ambil serve feed function. Okey, kita type serve. Okey, and then kita bila kita nak tengok survival, it is the relationship between the time to the event. So mesti ada dalam serve function tu ada time, ada event. Okay, time dia apa? Okay, variable kita tadi duration in days, and the event is event. Kita nak specify lagi event, kita guna double equal sign ni, and then kita specify the name of the event yang kita nak. In this case is death, and then kita associate to 1 to get the overall Kaplan Meier analysis. Okay, and then kita put type Kaplan Meier, and then data. Data kita guna data yang kita buat tadi lah, kita guna data. Alright. After we get the Kaplan Meier analysis, alright, we use the print function. Print function ni will produce the median survival time, and then the summary ni will produce the summary for the Kaplan Meier overall analysis. Okay, bila kita run, alright. Okay, yang keluar adalah input bagi print function and summary function. Yang ni dia tak keluar input. Okay, okay, this is the okay, this first two line is output for print function. Kita tengok dia punya end event dia ni, median survival time is 22 days with the 95% confident interval. Ada yang low, ada yang lower je lah, yang apa tak ada. Okay, and then start from this line and below, it is the output for summary function. Okay, we can look at the time, look at the number of event, look at the survival analysis. Okay, bila kita nak interpret in terms of time, number of event, and the survival probability, kita boleh buat macam ni. As the time increase, the number of event and the survival probability is decreased. So simple. For the overall Kaplan Meier estimate. Okay, I have put this in words, you can refer later on. And for the race, Kaplan Meier for race, sama juga, kita tukar. Tadi kita buat satu kat sini, and then sekarang kita tukar kepada race 2. Sama juga, dia punya code dia sama. Okay, kita put the summary. Okay, kita boleh tambah kat sini print function. Alright, km.race. Okay, kita run semua. Alright. Okay, sama juga macam atas, the first two line, okay, is the output for print. We can see here, there is a substantial difference in the median survival time for the Malay race and for others, in which Malay have a longer median survival time as compared to other races. Okay, and then kita punya output for summary untuk Kaplan Meier estimate for race also divided into two types, other races and Malay. Alright, kalau kita tengok kat sini, untuk other races, as the time increase, okay, the time increase 1, 2, 4, 12, 18, the number of event is constant, while the survival is reducing. Alright, for the Malay, as the time increase, the number of event and the survival probability is decreased. Alright. Alright, the same thing. Okay. The second part of the analysis is okay. Before this, kita buat descriptive analysis. Yang Kaplan Meier apa semua tu adalah descriptive analysis for survival analysis. Now, we have come to the regression analysis, the multivariate analysis for the survival analysis, which is the Cox proportional hazard regression. Okay, for the Cox proportional hazard regression, it is a semi-parametric analysis. Alright, we can highlight this. Okay, I'll mark down. It is very easy to customize your output. Okay, it is a semi-parametric survival. okay, to build the regression model. Okay, we can use the Cox proportional hazard model to measure the association between other factors or other covariates to the survival probability of it as individually or as group. Kita boleh tengok effect of satu variable to the survival probability or effect of multiple variable at the same time to the survival probability, which will produce the hazard function. Hazard function ni is the risk of dying at a given time t. Alright, kita boleh tengok kat sini the risk of dying at a given time of t. Okay, so the formula will be right this way. Alright, okay, you can use the this double dollar to create the space for formula. Alright, and then so we just take the justification for the Cox proportional hazard. Now we want to have a look the effect of variable sex, GCS, SBP, DBP to the survival function, to the hazard function in the Cox proportional hazard model. Okay, yang ni kita akan guna library yang sama, survival but different function. Kita akan guna Cox PH. Alright, Cox PH. Okay, kita bagi nama model tu apa yang kita nak, kita letak inverted error, kita guna Cox PH, serve function. Yang ni sebab saya nak integratekan dengan TBL summary, I will use a simpler code to do this. Okay, kalau sebelum ni kita buat time equal to duration in days, comma, event equal to event, double equal sign, specify what event we want, which is death. Okay, yang ni kita buat simple je. Sama je dia punya result. Dia akan keluar survival analysis juga with jimat masa lah. So kita just letak terus. Time dia apa? Okay, event dia apa? Alright, kita nak tengok effect of sex, GCS, SBP and DBP on the hazard function. And then kita guna data yang kita name tadi as data. Yang dalam Cox PH, jangan confuse, kita tak letak model macam atas. Yang atas tu untuk surfeit kita letak Kaplan Meier. Yang ni tak ada. Okay, yang ni untuk Cox PH tak ada. Okay, you can use summary function. Summary, alright. Summary function untuk summarize, Cox.this model. Okay, it will give you this type of output. Okay, kalau you tak biasa dengan output R, for me also I will confuse yang mana satu nak ambil kan, yang mana satu nak baca. Okay, kita boleh tengok ni adalah coefficient, ni adalah exponential of the coefficient, which is the hazard ratio, and then this is the p value, kita nak tengok dia significant ke tak. Alright, dan this is the global statistical test, which is the likelihood ratio test, the walk test and the score test. These three tests will give similar p value if the model is fit, the model is significant. So all the test p value is significant, thus the model is fit. Okay, that's all I want to have a look from this output. Yang lain-lain ni kita akan summarize guna gtsummary to have a presentation ready table. Okay, you can make it nice. Dalam survival, gtsummary ni kita guna untuk kita create presentation ready table sahaja. Kita tak guna dia untuk modeling. Okay, so kita letakkan nama model kita, kita letak pipe ni kita nak bagi tahu kita nak buat apa. Okay, lepas tu dan kita guna TBL underscore regression, kita letak exponential true to have the hazard ratio. Sebenarnya kita boleh customizekan lagi. Okay, I will use the TBL regression solely with exponential true and compare with when we customize the coding. Alright. This is the summary output. This is the, all right, very nice output. Okay, very nice output, easy to understand. You have the characteristic, the variable, you have the hazard ratio, you have the 95% confidence interval, you have the p value. Okay, let's see how we can customize this. All right, we want to customize the label. Okay, the label ni mungkin tak cantik kan, not meaningful, mungkin confusing sometimes, so you want to specific. All right, we just put comma label. Okay, list, sebab kita nak buat banyak label, kita type sex. Okay, sex kita letak ulat. Sorry, I use ulat. I don't know. We use the open and close the inverted comma. Kita nak letak nama dia sex. Alright, and then second variable is what? GCS. Alright, GCS. Okay, GCS. Kita nak letak nama dia sebagai Glasgow, comma scale. And then the third variable is SBP. Alright, SBP kita letak nama dia systolic blood pressure. Alright, the last one is DBP. Kita nak letak nama sebagai diastolic blood pressure. Alright, lepas tu, okay, kita nak tambah lagi, kita nak customizekan lagi. Kita keluar daripada ni, kita nak let's say kita nak letak okay, bold, kita nak bold the levels. Okay, the variable. Okay, kita nak buat lagi, kita letak lagi pipe, kita buat lagi, kita nak apa ni, apa jadi macam ni, kita nak buat bold P. So bila letak bold P ni, dia akan boldkan P yang significant. Okay, let's run this all together to have the customized output. Why ada error? The class X must be gtsummary class X. Sex ada koma dah. Alright, silap situ je. Okay, terang balik. Kenapa ni? Hal ni ginilah, dia very sensitif. Kalau tertinggal satu pun, dia akan menyebabkan error lah. Keluar tak? Glasgow comma scale. Kenapa ada error ni? Kita tak boleh nak bold the level ni. Alright, never mind, we'll fix this. Right, let's see. Okay. Alright, this should be working. Tadi ada error, kita yang sepatutnya penutup kata tadi duduk dekat sini, tapi kita pindah pergi sini, error terus. Alright, so now no more error. So kita bold the level. Okay, and then kita boldkan P yang significant. Alright, kita dah ubah sex, kita dah ubah all the levels into intended name. It has been nice, a very nice presentation ready table lah for me. Alright, now okay, we want to interpret. Okay, kita boleh interpret one by one of these variable, the effect of this variable into the hazard function. Okay, for sex. Okay, being female. Okay, being female, holding other variable at constant, we can have a look. It has 12% increase in the hazard function, in which male have 12% increased risk to death as compared to female when as compared to male when female have a stroke, but the p value is insignificant. Okay, the increasing risk is insignificant. However, for Glasgow Coma scale, holding other variable at constant, the increase in 1 unit of Glasgow Coma scale will reduce the risk of death among stroke patient for 20%. Okay, 0.8 ni kita boleh convert to percentage. 1 minus this times 100, we got 20%, and the p-value is significant. Okay, so the same thing for systolic blood pressure and diastolic blood pressure. You can interpret using the way that I used just now. All right, you can refer to this interpretation. All right, and then we want to test the last part of this. It's not the last part, this is the second last part, is the test for assumption of the proportional hazard. Okay, yang ni kita guna library surf minor. Okay, kita nak develop the proportional hazard assumption using the cox.zph function. So kita letak nama model kita tadi global true. Okay, kita run the proportional hazard, and then kita boleh plot the proportional hazard function kita. So run all these together. Okay, you can see the p-value for all covariate is insignificant, including the global p-value. Alright, kita tengok graph pula. So graph ni represent a graph for each covariate. Ni for sex, for GCS, for SBP and for DBP. Kita ambil contoh for sex, yang line dash line ni represent the plus minus 2 standard error from the baseline. Okay, kita tengok the red dots, okay, is nicely placed within the 2 standard error. Okay, and then along the timeline, the straight line here is the timeline. So kita boleh conclude that the assumption of proportional hazard of the assumption of proportional hazard is not violated. Okay, is not violated. Kalau the dots dia boleh jadi violated bila the dot ni berkumpul dekat satu masa saja, dia tak spread all over the timeline. So kalau dia macam tu, dia akan jadi violated lah the assumption of proportional hazard. Okay, the last one is interaction term. Okay, interaction term ni topik panjang, tapi I will try to simplify for you all. Okay, kita develop a model with interaction term. Okay, the same function use above, kita guna cox.ph surf function, kita letak dia punya time dia, variable time, kita letak variable event, and then kita nak tengok the effect of age, GCS, SBP, DBP, and the effect of interaction term between age and GCS. And then kita specify data mana kita nak guna, kita run, and then bila kita run yang ni, okay, kita cuba run dulu yang ni. Alright, kita tengok. Okay, result dia, age and GCS ni, dia insignificant. So, it means that the interaction term included in this model does not influence the hazard function. Okay, there is no interaction between the age and GCS. Okay, mungkin kita punya age ni dia homogeneous. So kalau dia heterogeneous, mungkin dia ada influence within the interaction term. Okay, and then kita nak compare the model with and without interaction term. Kita guna ANOVA function. So kita put the model without interaction term, the model with interaction term. Kita specify the test using chi-square and we run it. Kita tengok there is significant difference between these two models. But having said that, the model with interaction term indicate that there is no interaction between age and GCS. So I will choose the model without, okay, the model without interaction term as the model of choice. Okay, that's all for survival analysis. All right. In this tutorial, I will only explain yang tanpa graph lah. There is also ada satu graph, tapi yang untuk kita nak visualize the regression analysis, kita nak visualize the Kaplan Meier estimate, yang tu tapi kita boleh buat, okay, kita boleh tambah satu lagi, jangan kan, visualizing the Kaplan Meier estimate. Okay, yang ni visualizing the Cox PH regression model. Okay, macam mana kita nak buat? Alright, kita boleh guna gtsummary gtsummary. Alright, model kita tadi km dot race. Kita boleh state the survival median line, okay, dalam ni. Okay, kita juga boleh buat risk table. Okay, kita buat risk table true. Case, kita buat p-value true with confidence interval. Alright, lepas tu kita buat apa lagi boleh buat? Cukup lah kot. Array. Okay. Error. The data argument should be provided either. Kenapa should kita data lang. Wait, kenapa dia error? Okay, tak apa, never mind. Short practical, kita tengok balik, kita refer balik notes kita, never mind, biasalah tu. Oh, kena justify lah. Kita punya data apa dia? So data. Alright. Jadi tu. Okay. Now we can see the p-value is 0.38. Kita boleh tengok the median survival time for Malay race, okay, and other races is significantly different lah, tapi the p-value is insignificant. Alright, kalau kita tengok tadi 18 dengan 25 beza besar juga, tapi the p-value is insignificant. Alright. Kita boleh visualize the Cox model juga. Okay, kita tengok Cox model, how to visualize the Cox model. So kita boleh guna yang sama. Okay. gtsurf plot alahai gtsurf plot. Okay, kita buat dengan Cox yang ni tadi. Okay, dan boleh copy je yang lain sebab sama je kan. Ni sebenarnya banyak copy paste je. Apa pula? gtsurf is not found. Memanglah dia tak ada yang ni. Alahai, this table pun tak ada. P-value pun tak ada. Ini kita pun ada, boleh buat. Alright. Haha. This gtsurf plot is not found. Tu apa? gtsurf plot sekejap kan? gtsurf plot. Oh, never mind. Kita berhenti setakat ni dulu. And then I will update you later on the next video on the visualizing the Cox population hazard regression model. So I will stop here. All right. Now we